Imagine having the power to peel back the oceans, to sweep away millions of tons of desert sand and dense jungle canopy in a single motion, exposing exactly what lies beneath. For most of our history, archaeology has been restricted to the surface. This geographical limit led us to believe the ancient world was a collection of sparse, isolated outposts, with most of its story simply lost to the elements. But the record hasn't been destroyed. It's actually perfectly preserved, held in a state of suspended animation within the Earth's natural, impenetrable vaults. We have developed a way to access this archive. Advanced spatial mapping now allows us to scan through solid Earth and deep water, functioning as a window into a lost timeline. This ability to visualize the invisible is changing the narrative of human history. We are finding that our ancestors didn't just survive their environments, they re-engineered them on a staggering scale. Under the waves, the primary challenge is visibility. Traditional cameras struggle with murky depths, but a process called photogrammetry bypasses this. By stitching thousands of individual photos into a millimeter-accurate 3D map, we can effectively drain the sea digitally. This chart of Alexandria's harbor from 1890 illustrates the scale of the problem. For centuries, the Pharos Lighthouse, a legendary ancient wonder, was considered a myth or a massive exaggeration because the coastal waters were simply too vast to search manually. But modern mapping revealed a 200-ton granite doorframe lying on the harbor floor. It wasn't a legend, it was a physical artifact sitting in plain sight beneath 20 feet of water. This wireframe model demonstrates how computers use that specific doorframe to reconstruct the entire structure. The data proves the Pharos was an ancient skyscraper, reaching 330 feet into the air, the equivalent of a 32-story building. In the Baltic Sea, similar scans are exposing the infrastructure of the Viking world. This well-preserved hull shows the complex clinker construction that made these ships flexible and strong. These weren't just raiders, they were the backbone of a sophisticated ocean-going trade network that our scans are finally tracing across the seabed. By mapping these submerged sites, we are seeing the ancient world as it truly was, a heavily engineered and globally connected network, rather than a collection of isolated myths. In the Egyptian desert, we face millions of tons of shifting sand. To see through it, we use magnetometry. This tool detects minute magnetic variations in the soil, allowing us to spot varied structures that have been invisible for 5,000 years. 6 miles from the Nile at Abydos, researchers found something that shouldn't be there. The magnetic data showed massive uniform shapes buried deep in a plateau where the river never reached. This knot illustrates the discovery: 14 massive royal boats laid out in a parallel phantom flotilla. Each hull was protected by mud brick encasings, built to serve the pharaoh in the afterlife. This elaborate complex functioned as an early blueprint for the Valley of the Kings. Further south, the receding waters of Lake Nasser revealed the remnants of 15 megafortresses. This massive architectural program at Abu Simbel shows how the Egyptian state projected its authority hundreds of miles from the Nile, securing a 200-mile surveillance chain to guard its gold trade. Penetrating the sand shows us a more complex Egypt. These forts and ritual fleets suggest a sprawling authority that used massive infrastructure to manage its resources and defend its borders with military precision. In the tropics, the barrier to the past is a living one: dense, multi-layered canopies. To bypass this, we use LiDAR, airborne lasers that virtually strip away the leaves and vines to map the stone structures hidden beneath. LiDAR scans have located the lost capital of Sakhtsi, showing us that Maya civilization didn't simply vanish in the 9th century. We found evidence of advanced irrigation and channeled fields. These ancient communities were actively engineering their landscape to remain resilient through long periods of severe drought. Sometimes the data we need is held in the soil itself. Stratigraphy, reading the minute layers of the earth, allows us to document the exact timeline of ancient disasters like the eruption of Mount Vesuvius. These famous plaster casts at Pompeii tell a specific story: a slow suffocation under falling ash. But at the neighboring town of Herculaneum, situated even closer to the volcano, archaeologists were initially baffled by the lack of bodies. The forensic evidence in the ash layers provided a different explanation. The victims at Herculaneum were hit by a pyroclastic flow, a 1,000-degree wall of gas and rock that caused instant thermal shock. Whether they were building irrigation systems to combat a changing climate or facing sudden destruction, the Earth's layers hold the forensic evidence of how our ancestors actually lived and died. We are finding that ancient peoples were not primitive societies waiting to fail. They were master architects who manipulated their environments with incredible sophistication. By digitizing the Earth, we can move past destructive excavations and blind guesswork. We are beginning to see these monuments, like Chichen Itza, as part of a coherent, data-driven network of human achievement. Despite these discoveries, our map of the past is only 10% complete. The vast majority of our history remains buried, waiting to be found. We are currently living through the most prolific era of discovery our field has ever seen. The greatest archaeological breakthroughs aren't behind us. They are happening right now, just beneath our feet.